Hello, my name is Ron Meyer of Mitutoyo Europe. My presentation is about solving measurement problems for advanced packages. Nowadays, the demand for semiconductors is increasing in all kinds of industry. In the future, the demand for semiconductors will continue to increase, such as for IoT, generative AI, automotive case support, and smart factory support. Mitutoyo's quick vision range of CNC image measuring machines solves problems in the measurement of semiconductor packages, which is a particularly back-end process in the semiconductor industry. Since Mitutoyo began selling CNC image measuring machines in the 1990s, the connection with semiconductor package measurement has been inseparable. For example, measurement of an insertion mount dual inline package, DIP, or a surface mount quad flat package, QFP, posed following measurement problems. These packages are molded after wire bonding with IC chips on a lead frame. Measurement issues include the frame dimension measurement, measurement of the lead, tilt and twist, and along with this also the accuracy of image measuring machines had to be improved drastically. And that's why Mitutoyo introduced the Super QV and Hyper QV in the 1990s, as you can see over here. I think these packages are still widely used as legacy semiconductor packages for semiconductors that require high reliability even today. Next, organic packages. Organic packages with RDL on printed circuit boards became the mainstream semiconductor packages for personal computers. These packages were surface mounted with solder balls, and the measurement challenges included bump coplanarity, copper wiring line and space, and lamination misalignment of multi-laminated boards. Quick vision multi-sensor machines like the QV Hybrid are equipped with non-contact displacement sensors to evaluate bump coplanarity. Here you can see a detailed picture of a hybrid sensor on a QV machine. As the number of pins and high integration progressed, the management of copper wiring width and via diameter became important in flip chip ball grid arrays, which are logic semiconductors for PCs and data centers. Also, thinning lines and high aspects have progressed, so 3D measurement using an interferometer has become necessary in addition to image measurement. In order to achieve this measurement, Mitutoyo has developed the QVWLI, which is equipped with a white light interferometer. I'll talk more about this solution later. Here you can see the picture with a WLI sensor on a quick vision machine. Recently, 3D packaging technology has also advanced, and 3D connections using silicon interposers and other devices are becoming necessary. On the other hand, for packages that require high integration, such as smartphones, fan-out wafer level packages and fan-out panel level packages are the mainstream. In these packages, the high throughput measurement capability of the fully remodeled Quick Vision Pro series is very effective. More details later. Probably many of you know already, but I will shortly explain the structure of the vision measuring machine. The VMM captures the image by the image sensor placed in the main body on top of the microscope unit, and the image is processed on the computer side by our software QVPack. Accurate dimensional measurement is possible by combining the image information with the XYZ information on the three moving axes of the measuring machine body. So here is the image sensor behind this cover, placed on top of the optical system, the microscope unit. Here you can find the lighting unit, which is coaxial and ring light, and the XYZ movement of the machine is generated here from left to right, X-axis. The glass plate moves front to back as Y-axis, and the optical system moves up and down as Z-axis. Basic functions of the vision measuring machine. Here is a short summary of what you can do with image measurement. First of all, edge detection. It is possible to measure edge contrast of the image sensor in the XY plane. Can be in a selected box or another tool, but it is also possible to measure the contour shape by continuously acquiring the edge contrast as shown in the image below, so scanning the complete contour which is in the field of view. Also, height measurements by using the autofocus function is possible. It is possible to obtain height information by combining multiple areas placed in the screen. So it is also possible to measure the lead height of such leads. As you can see here, all these leads are selected and individually measured, but it's also possible to measure the loop height of wire bonding, as you can see in the picture below. In image processing, misalignment correction can be performed by detecting alignment marks and fiducials placed in the device. This section, pattern search. This video shows the actual measurement of the object to be measured using these image measurement functions. Perhaps you're already familiar or using Mitutoyo Quick Vision machines, but important to know is that about 2 years ago, Quick Vision was fully remodeled, and all models were equipped with so-called strobe lighting, increasing measurement throughput by about 40%. This video nicely shows how fast the edge detection with strobe snap works and how the measurement throughput is increased with the new generation of Quick Vision Pro machines. In this example, strobe snap made this measurement about 40% faster compared to traditional measurement methods. In addition, since strobe lighting is standard in Quick Vision Pro, it is possible to optionally install a synchronized measurement of the movement of the main unit and the strobe lighting, which is called the stream function. In this video, you can see the measurement using the actual stream function. This is an ordinary printed circuit board, but the measurement of the path position is measured by synchronizing it with the strobe lighting without stopping the movement of the main unit. Also, as I will introduce later, the printed circuit board is intentionally warped, but you can see that it is measured by automatically following the warp by tracking using a laser called TAF. As a function to improve throughput, this tracking autofocus is effective in conjunction with the stream function you just saw. Normally, if the object to be measured is warped, it is necessary to perform image autofocus again and again before each image capture at the measurement target. By using a tracking autofocus called TAF, it is possible to automatically track the deformation of the measured object and reduce the loss of time caused by refocusing. So here you can see the camera moves up and has to refocus to get a focused image. And here again, and with TAF, this is not required because it follows the contour of the workpiece. Tracking autofocus. Using a laser, the camera can instantly track changes in the Z height of the object being measured. And this tracking autofocus function can also be used with connector terminals as shown in the video example, as it can be tracked even in non-continuous shapes. By the way, in this case, we were able to shorten the measurement time by about 65%, from 38 seconds to 13 seconds. And this can be realized by using the Z-axis hold function, which even more eliminates Z-axis movement and saving time. In this video, we use the stream function and TAF to measure cavity and different heights of wiring compared to traditional methods. So in the left video, you can see stream and TAF combined. In the right video, the conventional vision measurement method. Although it is a measurement of only one side, the measurement that used to take 35 seconds with the conventional measurement method was improved to 7 seconds by using the stream function and tracking autofocus function, which is about 80% more throughput. This is a bit of a long introduction to the features of the product, but I would like to introduce fan-out waver level package measurement solution using the stream function and tracking autofocus function. It is possible to output coordinate correction data to the equipment used for rewiring formation by measuring the entire position and angle deviation of each die with the stream function in the post-process of the first die. Even if the wafer or panel is warped, it is possible to reliably measure the position of the die by using tracking autofocus. By the way, when measuring 25,400 dies placed on a 300 mm wafer, it takes about 34 minutes to measure, compared to 183 minutes with the conventional method, and the throughput is improved by about 80%. Although the number of dies in this video is different, it nicely shows the actual measurement with the stream function and tracking autofocus function. In order to see the performance of the TAF, the wafer is tilted by 10 mm, but as you can see, it is properly followed in the Z direction and measured. The video just shown was an example of measuring in a fan-out wafer level package. But it is also possible to measure the position of a die placed on a lead frame such as a power semiconductor or an organic substrate using the stream function or TAF. By passing the measured position and tilt information of the die to a laser processing machine, it is possible to improve the accuracy of longitudinal wiring connections. Next, I will introduce the QuickVision WLI Pro, which is equipped with a white light interferometer in the image measuring machine and can measure dimensions and analyze surface roughness from 3D shapes in addition to image measurement. This is the detection principle of a general white light interferometer, but to explain it simply, it is possible to generate 3D data by placing a reference mirror in the optical path and detecting interference fringes generated by two luminous fluxes. This is an example of an application using QVWLI on an advanced package board. With the improvement of semiconductor package performance, thinner lines and higher aspect ratios are progressing, making it difficult to detect edges using conventional image processing. QVWLI uses a white light interferometer to measure the top diameter, bottom diameter and depth of via processed with a CO2 laser or UV laser as shown in the illustration, as you can see over here. WLI can also be used for line and space measurement of wiring formed by semi-additive construction methods and measurement of conductor thickness, as you can see over here. In addition, it is possible to measure the surface roughness after coarsening the correlated material, what you can see over here with the analysis. Here you can see a video of the line and space measurement with QVWLI Pro. This is the analysis of a 2D section, and here you can see the 3D topography result. And in this video we show you the top diameter, bottom diameter and depth measurement of vias with the QVWLI. These are the dimensions shown in the case of HBM tags that we had manufactured externally and verified with QVWLI. This is a SEM image of a gold-plated bump on nickel. This was measured with QVWLI, and the bump height and bump pitch were measured by cross-sectional analysis from the 3D shape. The measurement results of the QVWLI of each layer are also very close to the SEM results. Lastly, I would like to introduce a quick vision model which is equipped with a near-infrared light source. In order to emphasize edge contrast, quick vision has a color illumination type with RGB and LED elements for each wavelength, the red, green and blue illumination sources. Now I will introduce the measurement application of advanced packages that are becoming more multi-layered by mounting near-infrared light sources in vertical AP illumination and ring lighting. First of all, as a general case, the coupon of the lower layer may be processed with a laser for the alignment of the laminated board, but the coupon may be damaged by laser processing and may not be able to measure accurately, as you can see here in the left image. By using a near-infrared light source, as shown in the figure on the right, it is possible to observe and measure the coupon through the resin, and in this way it is possible to omit the laser processing process. In addition, by taking advantage of this characteristic of transmitting resin, the range of evaluation can be expanded, such as measuring the accuracy of UV laser processing by observing and measuring built-in components arranged in correlation materials such as silicon bridges. The quick vision devices you saw are also compatible with EFEM, wafer loaders and robot transport in order to respond to automation in semiconductor manufacturing processes. Please feel free to contact us. In addition, the stream function and tracking autofocus function introduced in the Quick Vision Pro can also be used in other applications in the semiconductor manufacturing process, such as measuring shower heads, electrostatic chucks, sealing molds, and probe cards IC sockets. Any questions? Thank you for listening to this presentation. We will be glad to receive you in our booth in the exhibition hall for further detailed explanation of the technologies we can offer you as Mitutoyo Corporation. Thank you.